Section 4.5 scatter plots. Essential question. How do you find the rate of change for a scatter plot? Alright, so here is your first example. And it says, which scatter plot shows the most accurate line of best fit, and then explain the trend of the graph. So remember, a line of best fit is a line that kind of goes through the middle of the data points that shows which way the trend is going. So which way is the data headed? Now remember that a line of best fit has to be exactly that, a line, and you do not connect the dots. So the dots are not connected. You're drawing a line that goes in the direction the data is headed. So we're going to look at 4 scatter plots here, talking about groceries that have been purchased. So they're relating the number of grocery bags you need to the number of items you purchase. So let's go through and look at all 4 of these to figure out which one has the most accurate line of best fit. So first of all, let's look at letter X. Now letter X has a line going through one of the dots, but none of the rest of the dots fall on either side of the line. So I would say that that one is not the most accurate line of best fit. When you have all of these dots that didn't fall near the line, that's not a great line of best fit. All right, let's look down here at letter Z now. Letter Z has a few dots right here that fall on the line, but all of these here and these up here aren't anywhere near the line, so I would say that's not a great one. So now we've narrowed it down to letter Y and letter W. Now look at which one has about the same amount of dots falling on both sides of our line. That would be letter W. This one has most of the dots falling below our line. We want them on both sides. So letter W has the most accurate line of best fit. Now let's explain the trend of the graph. So we are comparing grocery bags as our X value to the number of items purchased, our Y value. Now if you have troubles looking at this graph and writing a sentence about the trend, try taking 2 ordered pairs that fall on your line and using that to help you. So I'm going to use this dot right here, which is about 311. And I'll use this dot that also falls on the line, which is about 726. So in order to write my sentence, I first of all look at what my X values are doing. Then I look at what my Y values are doing. So my X values are going from 3 to 7. So my X values are increasing. My X value is the number of grocery bags. So we're going to say, as the number of grocery bags increases. Now let's look at our Y value. Our Y value goes from 11 to 26. So that value also increases. Now our Y value is the item spot. So as the number of grocery bags increases, the number of items spot increases. So really, if you think about it logically, the more items you buy, the more bags you need. So that'd be another way to say it. The more bags you need, the more groceries you bought, or vice versa. The more groceries you bought, the more bags you would need. All right. So this one says the graph shows a line of best fit for data collected on the amount of liquids consumed by a runner in relation to the distance he ran. So if you look at the titles of our graph, we've got liquids consumed, so how much did he drink while he was running, the distance he ran, and the amount he drank in ounces. Okay, so it says use the line of best fit to answer the following 2 questions. So the first question is, what volume of liquids will the runner consume when he runs 7 miles? Now keep in mind you have to have a line of best fit in order to make a prediction. That's a big part of what a line of best fit is used for. So it shows us the trend of the graph and allows us to make predictions. So if you don't have a line of best fit, you really can't make a prediction without it. Okay, so when he runs 7 miles, so we're going to go over to the 7 under miles. And I'm going to follow my line of best fit up until I hit my red line. So I'm going to start at 7, follow it up until I hit my red line. So this dot right here is the new one I made. Let's look at what number that's at. Well, it's right in between 9 and 12. So we'll say it's maybe 10.5. And if you think about it, how many ounces can you drink? You can drink half of an ounce. So I would say 10.5 fluid ounces. And I would use your label there because they want to know how much, what volume of liquids. So 10.5 fluid ounces would make sense. All right, let's go to the second one. If a runner consumed 15 ounces of liquids, how many miles did he run? So now we're going to go on our y-axis to 15. And I'm going to go across until I hit my red line. We're right here at the edge of our graph. So let's look at what number that is. Well, we don't have a number here, but you can see we're counting by ones. So this would be 10. So that would mean he ran 10 miles if he consumed 15 ounces of water. So that is how our line of best fit can help us make predictions. All right. The wind chill for a 15-mile-per-hour breeze is shown. Write an equation for the line of best fit. So they give us a line of best fit down at the bottom. And actually, all of our lines fall on our line of best fit. Now, one thing I want you to notice before we write an equation, notice that our x-axis is actually right here, and then our y-axis is right here. So that's a little bit different because we go into negatives because we're talking about wind chill. So wind chill can get into the negative numbers. So there is our x-axis. Here's our x. Here's our y. Okay, so if I need to write an equation, the form they want us to write it in without saying is y equals mx plus b, where m is the slope and b is the y-intercept. Now there are actually going to be a couple of ways that we can figure out what our slope and our y-intercept are. So I'm going to show you a couple different ways. So I'm going to split the screen in two here, and I'm going to show you two different ways. All right. So one way that we can find the slope is by taking two ordered pairs on our line. Now, it really doesn't matter which ordered pairs you choose. I like to choose ones that only have positives, though. All of these dots fell on our line, so I can pick any two ordered pairs from the chart. I want to pick two dots that are on my line, though. So if in the future you have some ordered pairs that aren't on your line, I wouldn't pick those. So if I use 25, 2, and 39, then I can label those and use my slope formula. So my slope formula is y2 minus y1 over x2 minus x1. So 9 minus 2 is 7. 30 minus 25 is 5. So 7 over 5 is our slope. Now let me show you another way you could find your slope. Now remember, slope or rate of change, is also the same as change in y over the change in x. So let's see what happens if I do change in y over change in x. So that would mean I'm doing 9 minus 2, which is 7. 2 minus a negative 5, which is 7. Negative 5 minus a negative 11, which is 7. So we're going to get all 7s on that side. So I'm going to put a 7 on top. And then if I do change in y, 30 minus 25 is 5. 25 minus 20 is 5. 20 minus 15 is 5. So you'll notice they're all 5 on that side. So we got the exact same slope no matter which way we did it. So you can either use the slope formula or change in y over change in x. Doesn't matter which one you choose. Okay, now the second thing we have to find is our y-intercept. So I'm going to show you 2 ways to find our y-intercept. So the first way is we know we have a slope. We also know we have these 2 ordered pairs and a bunch more in our table. So if I take a point and a slope, I should be able to do my slope formula, or my point slope formula, to write my equation in slope-intercept form. So let's just I'll pick this ordered pair just because. So y minus 2 equals 7/5 times x minus 25. So if I draw my train tracks and I distribute, so 7/5 times x is 7/5 x. Then if I do off to the side, 7/5 times a negative 25 over 1. So 7 times a negative 25 is negative 175 over 5, which equals 35. So this right here will turn into a nice number, negative 35. Add 2 to both sides. All right, y equals 7/5 x minus 35. Let me just check one thing really quick. All right. So the other way to do it, so now we have an equation in slope-intercept form. Our other way to do it would be to look at our table, and we know that, well, you can kind of tell by this graph right here that that's where our line crosses the y-axis. So the other way to tell which one would be accurate for our y-intercept is look at our table. When x is 0, y is our y-intercept. So that right there tells us our y-intercept is negative 31. So then if I put that together, y equals 7/5 x minus 31. Now you'll notice that our y-intercepts are slightly different from each other. One is negative 33 and one is negative 31. The one that's a little bit more accurate is where the 0 in the table was, saying that it's negative 31. But if you see questions like this on Study Island, you can just, usually they'd only have one of those y-intercepts as the correct one, so that you wouldn't run into that problem. All right, last one. Use the line of best fit to approximate the rate of change. Now, rate of change on this one. Rate of change, remember, is the change in y over the change in x, which is the same thing as slope. So rise over run. So really all I'm going to do is find my rise over run to figure out this slope or this rate of change. Now keep in mind, if we had two blue dots that fell exactly on our line, we could use those to find the slope or the rate of change. But if you look at this graph, we don't have any dots that fall directly on that line. So I can't use any of those ordered pairs to help me find the slope. So what I'm going to do is I'm going to find two spots where my black line nicely crosses a grid line. So I would say that this spot in the corner here, and if I follow my line, the next spot where it touches exactly in the corner, I would say is here. Some of you might say that one, but I don't think it's perfect. So that's why I wouldn't use that one. So if we start here and count our rise up 1, 2, 3, 4, 5, and our run 1, 2, 3, 4, 5, 6, 7, 8. So I would say our slope is 5/8. So if you don't use an exact coordinate point, it may end up slightly off. And that's probably what happened on this last problem when we ended up with two slightly different y-intercepts, is that the ordered pair we used probably wasn't perfectly on our line. So we used the ordered pair 25-2. It probably wasn't perfectly on the line, and that's why it ended up slightly off. That's why we ended up with slightly different y-intercepts. So you can need to be a little bit careful on these ones. And when you do them on Study Island, you'll have a multiple choice question, so you should be able to figure out what the correct answer is. Summary.